Consider two blocks M1 and M2 placed on a rough horizontal surface. The coefficient of friction between each block and the ground is K, and M1 is lighter than M2. The two blocks are connected by a spring which is initially unstretched. Now suppose we apply a horizontal force F on M1 pushing it towards M2. Our goal is to find out the maximum value of this force such that the block M2 does not move. To analyze this, let the spring constant be equal to Ks. Since M2 remains stationary, block M1 will move and will compress the spring. Let the compression of the spring against the external force F be L. Now look at block M2. The spring pushes the block M2 with a force Ks into L. This force is opposed by the static frictional force. So I can write Ks into L is going to be equal to the static frictional force. Now in the limiting case wherein my F is equal to F max, which is the maximum force that I'm applying on M1, the static frictional force is going to be maximum, which means that Ks into L will be equal to Km2 into G, wherein Km2 into G is the maximum static frictional force on M2. Now let's apply the energy conservation on the system. The net work done by F equal to F max on the system is equal to F max into L. Now this work done gets divided into two parts. The first part is the energy spent on the work done against the frictional force while M1 moves by distance L, right? So this component is nothing else but K M1 into G into L, which is the frictional force acting on M1 times the distance that M1 moved. And some part of F max into L is stored as potential energy, which is also equal to the work done on the spring. Now this potential energy of the spring is nothing else but half into Ks into the length of the spring compressed, that is L squared. Now I get the equation as F max into L is equal to half Ks L square plus K M1 into G into L. If I divide both the sides by L, I get F max is equal to half Ks into L plus Km1G. If I solve these two equations, I'll get the value of F max as Kg into M1 plus M2 by 2. And this is my answer.